we will present the model and the ontology of the signal. First, we gathered with a crawler several datasets from different museums, more than 10 museums. And the problem with this dataset is that you can have fields with different name, date, time chronology, with the same types of information. And these information are in different language too. So the problem is how to gather this information in a unique model. So we choose SciDoc CRM, which is a conceptual reference model elaborated for aligning and gathering data from different museums. We choose SciDoc CRM because it's in an international standard, an ISO norm, and we use the currently last version 6.2, and we use it because it's currently used in other projects dealing with cultural heritage data. And it allows to integrate cultural heritage information in single and common environment. And moreover, it's generally implemented in RDF. So, in order to define the signal model, that data model, we have several steps to follow. First, we study the structure of various cultural heritage catalogs and databases. We have to define the data information groups which were interesting for our project, not the group for managing the item from the museum. It was not interesting for us. And then we select in the SciDoc CRM core model the property and the classes we needed to express the information we selected. And moreover, given that SciDoc CRM is a high-level ontology model, we have to create new classes and properties to describe the characteristics of the fabrics, and the characteristics we will be extract from the text, the text field in the catalog of the museum. So we define the signal data model, and the classes and the property of this data model are available in web application developed by the Lara in Lyon. And we can search the classes with their definition and the property linked to the classes. Here are some classes from SciDoc CRM, the basic version of the SciDoc CRM. For each dataset, we define the mapping room, so how to map each field with SciDoc CRM class and properties. You have here an example from a velvet created by Gaspard Grégoire at the beginning of the 19th century, which is at the moment in the Museum Textile in Lyon. So we map the dataset. You have here the field as labeled in the museum. And here you have the main classes we use for express the information, and here we express the classes and the property and for each kind of information. Then we express the mapping in visual representation, kind of graph here. So you can see for the example, the graph express the measurement, the information about production, about the creator, etc. And as you can see, and to link with the presentation before, we have one of the problems is that some fields are mere plain text description, and how to the automatic text analysis will extract this information from this observation. And in the plain text, we have information about the production, the process of production of the textile, and we have represented, modeled the production of the textile, the process of the production of the textile, and create new classes. And this leads to the creation of a signal extension to the SciDoc CRM for describing fabrics. And we use already existing class, but we create an extension for dealing with the production of textile artifacts. This is available in the management environment for ontology developed in the LARA, and you can get now the classes and property in OWL RDF. And we can also, in this environment, we can also align our ontology with other ontology. For example, with European data model, directly here. You can see here an example. You can see that agent, the class agent of the European data model, is equivalent, an equivalent class to the actor of the SciDoc CRM. The next step will be to model how to model the provenance of the new information that will be generated by a text analysis and image analysis process. So we are at the moment working on this problem with we could use some data model like Prov, CRM Dig or CRM Inf.